Hello, everybody, and welcome back to another Mystery Box Function Challenge. In the purple mystery box, we have some mystery math, and your challenge is to figure out what that math is. You can pause this video, use the link in the description to get to this page, and plug in as many numbers as you want in the top and see how they're transformed as they come out the bottom. We'll keep track of your ins and your outs here in this chart and plot them as ordered pairs so you can see the shape that this math makes. So try that out, then come on back, watch the rest of the video, and see if I get the same thing that you do. All right, let's start off with a 0. Whoa, okay, that's a little different. So 0 gives us infinity. Have we seen something like this before? Maybe. Let's put in a 1. 1 gives us 2. So it's not exactly what I had first thought. Let's try a 2. And 2 gives us 1. Well, now this is looking like a line, except something weird happens around 0. Let's try 3. Aha, okay. I think I know what's going on now. And actually, I want to put in a 1/2 so that we can see. Yeah, that's what I thought. Okay. So because we got infinity at 0, I think this line is going to keep going up and up as close as it can get to 0 without actually getting there. And I think this one's going to go down and down and out as close as it can get to 0 on the y without actually getting there too. And we have seen a shape like this before. I'm just going to put in some negative numbers, and what I'm expecting, because I think I know what this is we're going to see a similar thing, symmetrical about the origin over here. So let's put in a -1. And that gives us a -2, good, and a -2 should give us a -1. All right, and a -3 should give us that -2/3. And I'll just put in a -1/2 just to be symmetrical here. Yeah, so we're getting these two arms in the first quadrant and the third quadrant, and there appear to be some asymptotes, so those lines of values that the function can never reach. It goes up to infinity before it gets to 0 on the x, and it goes out to positive and negative infinity before it reaches 0 on the y. So do you recognize what this is? Well, I think the basic function here is 1 over x. But that can't be what it is, because if I put in a 1, 1 over 1 would be 1. And we've got a 2. And if I put in a 2 here, I would get 1/2, but I've got 1. So what is this? Well, this would have been 1 over 1, and this would have been 1 over 2, but it's 1. So it looks like both of these are double. Does that go with this one? 1/2. So 1 over, that one takes some complicated calculating. 1 over 1/2, what is that? Well, you could multiply by 2 over 2, and that would get rid of that. It put the 2 on the top and the 1 on the bottom, so that would equal 2. So 1 over 1/2 should give us 2, but it gives us 4. Here we got 1 when we got 2 when we should have gotten 1 if this is 1 over x. So it looks like it's all just doubled. So we're basically taking this function and multiplying by 2, which can be simplified. You just multiply the 2 across the top as 2 over x. Does that work for the negative numbers as well? You put in a -1 on the bottom here. 2 over -1 would be -2. You put in a -2, that'd be 2 over -2, that'd be -1. Yeah, that looks right. You might want to try a couple other points. Maybe we'll try one more. What would I get if I put in a 4? So if it's 2 over x, I would put 2 over 4, and that should be 1/2. So if I put in 4, I should get 1/2. Let's try that. So there's my 4. Do I get 1/2? Yeah, I did get 1/2. Okay, so I'm pretty confident that this is the function f of x equals 2 over x. Let's take a look. Yes, f of x equals 2 over x, and we can graph that. Beautiful rational function graph with the two arms going off to infinity. Lovely. Well, how did that go for you? I think that was a toughie. Did you recognize that shape of the rational function with the x on the bottom of the fraction? If you did, how long did it take you to realize there might be a 2 on the top? Let me know. Thanks, everybody.